Get ready for some mind-blowing moon facts. Between 69 and 77, Apollo's cool gadgets picked up an astonishing 28 moonquakes during their missions. Scientists were totally gobsmacked. How could there be quakes without those massive moving tectonic plates we have on Earth? Well, it took us a while to figure out the real reason behind these lunar shakes. But here's the jaw-dropping part. We've finally cracked the code on what triggered those moonquakes. The initial theory was that meteorite impacts were the main culprits behind the lunar shakes, and it makes sense since our moon is basically one giant crater map from all those cosmic collisions. But the truth is a bit more complex than that. But here's where things get really interesting. A whopping number of these moonquakes can't be explained by just meteorite impacts alone. The reason why is that some of these quakes registered an insane 5.5 on the Richter scale, which would require a truly enormous object to cause such massive shockwaves, almost as big as a skyscraper hitting our planet. With this puzzle piece not fitting the initial theory, scientists had to shift gears and start investigating other possible causes for these mysterious moonquakes. The researchers went back to basics, analyzing thousands of lunar photos side by side with those seismic records. What they found was mind-blowing. Our trusty moon is actually riddled with deep cracks and fractures. Now, this discovery alone wouldn't solve the mystery, but it did offer a huge clue. These fault lines were clearly linked to those powerful moonquakes we just talked about, and there's no way meteorites could have caused such extensive damage. This new evidence had scientists pointing fingers at another explanation, one that would change our understanding of the moon's history forever. Get this, researchers found that moonquake hotspots were a whopping 19 miles away from these major cracks on average. That's like right next door in space terms. So it's clear these fault lines are the real deal, the epicenters of our moon's seismic activity. And here's another fascinating twist. Most of these moonquakes happened when our satellite was at its furthest point from Earth, known as apogee. Think of it like being stretched to your limits, and that's exactly what was happening to the lunar crust. The extra gravitational pull made those pre-existing cracks even more prone to breaking, causing some serious moon-shaking action. But here's the thing. Our planet doesn't always get to be the bad guy causing chaos for the moon. It's actually more about what's happening beneath our lunar neighbor's surface. You see, the interior of the moon is slowly cooling down over time, and as it does, it's compressing like a shrinking cookie. This pressure buildup is what leads to the moonquakes we've been talking about, not just Earth's gravitational pull. Picture this. Our moon is like a fresh grape, but over time it's drying out and shrinking into a wrinkly raisin. As it contracts, its outer layer can't withstand all that pressure, causing tiny cracks to form on its surface. Meanwhile, deep beneath the crust, this gradual squeeze is triggering massive shockwaves, similar to those seismic machines detect as moonquakes, and guess what? Up to 25% of these moonshakers are directly linked to the moon's own cooling insides. Moonquakes could be a major red flag for anyone planning to live on the lunar surface one day. Imagine astronauts suddenly caught in the chaos of a collapsing station after a series of intense shakes. That's why NASA is going all out, deploying 10 more seismographs across the moon to map out the calmest spots where quakes are less likely. But here's the real kicker. All this cooling and contracting over 100 million years has actually shrunk our beloved moon by an astonishing 150 feet or 50 meters in diameter. You might think that since the moon is smaller now, it must weigh less. But surprisingly, it's actually shedding some serious mass. Let's dive into what would happen if our moon lost a huge chunk of its weight, at least half of it. The effects would be mind-blowing. But did you know that an even lighter moon might have made life on Earth impossible in the first place? Here's the thing, if the moon were only half its original weight, those powerful tidal waves we love and need would become super weak. And get this, tidal action was actually a key player in kickstarting life on Earth. It swept away carbon-rich nutrients from our coastlines, providing the building blocks for the very first living organisms. But that's not all. A lighter moon wouldn't be able to help stabilize Earth's axis tilt like it does now, making long-term survival of any emerging life forms super tricky. So if our moon seriously lost its mass, get ready for some wild temperature swings. Seasonal changes would become super unpredictable and extreme, with ice ages giving way to scorching heat waves almost instantly. Most living things struggle to cope with such drastic and constant shifts, making it tough for life as we know it to thrive or even stick around at all. In short, a moon that's lost its mass could spell the end for life on Earth, or at least make it unrecognizable. But don't worry, folks, we won't be experiencing an icy hot roller coaster anytime soon. Here's why the moon might get squeezed by Earth's gravity, but that squeeze doesn't actually change its mass. As it gets denser, its mass stays put. Now, when it comes to our planet, a tiny bit of weight is being lost each year, about 50,000 tons total. The Earth's core keeps burning energy and shedding roughly 16 tons of mass annually. Let's dive deeper. The real MVPs when it comes to weighty losses are hydrogen and helium. They're so light that our gravity can't hold onto them, causing them to float off into space. We lose up to a staggering 95,000 tons of hydrogen and around 1,600 tons of helium every year. Now, don't be confused, these numbers aren't a mistake. It's actually true that while the Earth is shedding some mass, it's also picking up new weight from space. So in the grand scheme, our planet's mass isn't as static as you might think. But here's a cosmic twist. While we're losing some serious weight in space, about 40,000 tons of stellar stardust comes crashing down on our planet each year. When you do the math, it turns out that despite these gains, our world is still shedding more than 50,000 tons annually. Now, before you start panicking, think of this as a cosmic game of scales. That massive loss might seem daunting, but scientists say it's just a tiny drop in the Earth's enormous bucket. We're talking about a whopping 1 in quadrillionth of 1% of our planet's mass. So, rest easy, Earth is safe from disappearing anytime soon. Let's put Earth's hydrogen loss into perspective. If we're being super generous with time, our planet might take trillions of years to say goodbye to all its hydrogen, floating away into space. But hold up, we're not even close to reaching that cosmic deadline. Scientists predict both Earth and the Moon won't make it that long. Now, you might wonder, does this mean the Moon's mass is changing? Well, so far, nope. However, researchers have discovered a clever silver lining: cracks in the lunar crust could actually make it way easier for us to dig up valuable minerals on the Moon. Who knew space rocks had a hidden benefit? Imagine digging up a treasure trove of valuable stuff like gold, platinum, and even yttrium, a key ingredient in those sleek computer screens. That's exactly what scientists have found hidden within the Moon's crust: regolith, or lunar soil, packed with precious resources. So, it's no wonder some folks see the Moon as a cosmic gold rush waiting to happen. But, back in 1979, the UN stepped in and laid down the law with the Moon Treaty, a pact that promises to keep the Moon's usage strictly peaceful and sustainable. Sounds great, right? Well, there's just one tiny catch: who gets to decide how all these resources are regulated and managed? And what are the potential consequences for our lunar neighbor? But here's the thing, not every country with space ambitions agreed to the Moon Treaty. Major players like China, the US, and Russia are actually planning to start mining lunar resources soon, so we can't wait to see what their strategies will be. But what if they don't play by the rules? What if the Moon gets overexploited? We'll just have to keep watching. And speaking of unexpected twists, in 2017, tiny Luxembourg threw a curveball when it passed a law claiming ownership of any space objects its companies discover. Talk about reaching for the stars. So, Luxembourg just made a pretty bold move. They're saying if their companies find something valuable in space, it's basically theirs. This tiny country is already a big player in the space industry, and now it looks like we might see their flag on the Moon soon. But here's the thing, our beloved Moon is actually shrinking, and this, combined with potential mining, has us wondering, could we be messing with its mass by bringing Earth-bound resources back to our planet? Is it possible that active lunar mining will cause our Moon to lose some of its gravity, defying magic in the years to come? Now let's dive into the possibilities if we decide to open this fascinating and slightly unsettling Pandora's box. What would happen if we heavily mined our Moon? And is it even feasible to create an artificial one in case things go awry? Share your thoughts in the comments below. I'd love to see what you're thinking. If you enjoyed today's video, don't forget to hit that like button and subscribe for more edutainment content. Also, enable notifications so you won't miss when I dive deeper into this lunar conundrum in an upcoming video. Let's keep the conversation going and spread the word about our amazing channel. Invite your friends, and let's explore space together. Thanks for joining me on this intergalactic journey. Your curiosity and engagement fuel my passion for edutainment, so thanks again for watching.